Okay, so now we're looking at section 12.6 for Math for Liberal Arts, MGF 1106. And the topics for today is linear regressions. Now, mainly in this discussion here, we're going to be looking at what's so-called the correlations, coefficient. And the next topic we're looking at linear regression line. Linear regression line. And another name for this linear regression line here is sometimes we know the linear regression line here as the best fit line. So you probably have heard of this term somewhere, the best fit line. Okay. All right. So now the idea, first of all, the fundamental statistics that we've learned before. The type of statistic that we've learned before is only for one data set. So you can just say, if you simply just collect like data on age, and that's just simply one. That is just simply one data set. Now we're looking at two. The goal here is we're looking at two. We are looking at two data sets together. That's the idea. So it can happen in sometimes like this. I'm making up a scenario here that suppose we're collecting. I'm making for myself a little table here, and the quick example I can see is that sometimes you can imagine that you're making a table. You're collecting information from 5 students. It could be 6 students, but then for the set of students that you're collecting data, you're looking at their ages. So in the set of 5 students that you're looking at, their age could be, some of them is 17, right? Another person could be 18, and there is also another person being 17. There's another person being 19, and there's another person being, say, 20. So that's you collect it. So once again, the basic example here, the basic idea here is that it could be that you are collecting, information from 5 students, and then first within these 5 students, what you're looking at here is their ages, and also besides the ages, you can think of you collecting their pop quiz score. So pop quiz score, right? So now for pop quiz score, it could be like this person of 17 years of age right here. This person can score about, let's say I'm making this data up, so it can be like say 15, and this person right here is about like a 20, and this person right here is about like a 17, and this person right here is about also scoring a 19. And this person here is scoring like a 25 right there. Okay, so the idea now is that we got 5 students, and for each student we collect 2 types of data here. From each student we collect the age and we collect the pop quiz. And now the point now is that with the two data set here, so this is one data set, right? This is data set 1 right here. Data 1, and this row right here at the bottom of the table is data set 2. Right? And the idea now is that I would like to see, is there some kind of relationship between the age and the pop quiz? The whole point is that we would like to make some kind of conclusion to see if age is going to have something to do with pop quiz. Because who knows? Sometimes it could be like the older you are, the more mature, so you can score higher on the pop quizzes compared to like the younger student. Or it could be the opposite way around, right? So the point now is that I would like to look at the two relationship here together, so that I can see how the age factor is affecting the pop quiz score, or you can look at the way the opposite way around. So, and the relationship between the two factors, that's what we understanding that as the correlation. So, relationship, right? The relationship between the two data sets, right, is the correlation. Right? And then the correlation here, the correlation is to be measured by the correlation is measured by a single coefficient, by a single number called correlation coefficient. Okay, and that's the term that we're about to learn today. And so what I'm about to do now is I am going to give you a formula to quickly compute the correlation coefficient. Right? Alright, so here we go. One thing that I have to warn you ahead that the formula I'm about to give you here, it's to help you find the correlation, so it's for the same purpose. But then the formula I'm giving you here is it's going to look different with the formula you find in the textbook. And personally, I find this formula I'm about to give you right now is easier to use compared to the one that you see in the textbook. So you have your choice. You can follow the formula from the textbook, or you can use my formula. Okay? So here's the thing. Suppose data values, right, in data set 1 is x, and suppose data values are the data values in data set 2 okay, is the y variable. Okay? And so what I'm doing here is that my formula, the correlations is my correlation, which is indicated by an R, is given by the formula. And I'm about to write the formula right now. So the correlation is given by the formula 1 over n minus 1. And then times with the sigma, which is the sum, x minus x bar divided by s of x. And then times with y minus y bar divided by s of y. Okay? So this is my formula to find the correlation coefficient. And then that correlation here has a lot of meaning. So now, as a quick interpretation, the n in my formula over here represents the number of data values. So like say if you think back into if you're looking back at the data set, the two data set between age and pop quiz, then you can see that there were about like the n here was 5, right? And then the x bar here is the mean. It's the mean of all x. So basically, I'm talking about the mean of all data values that are x. And then y bar here is the mean of all the y values. Okay, and x bar is the mean value, right? Is the mean of all x values. Okay, I'm going to add the word x values in. Okay, and also s of x right here is the standard deviation. So now once again, that's the standard deviations, right? Standard deviation of all x values. And then the S of y here is likewise the standard deviation, okay, of y values. Okay? And so that's what it means right here. So I have shown you in some of my other video earlier that how to find the standard deviations and how to find the mean for each data set, right? So the point now is that you are going to look into each data set separately, right, and find for yourself the mean value for each data set, right, and you have to find for the standard deviation for each data set. So yes, do expect that your work is going to be long, okay?